Okay, welcome to lab number 4. So this is the lab like vibration isolation. So for this one we are using the NILVs, the accelerometer and the motor, and with the external power supply. And for as we did on the previous lab number 4, we use this accelerometer, and we'll do it on the last experiment. We just use one of the output for the reading, analog voltage reading. But for now, this lab we use the 3 of the output X, Y, and Z. And here is the we are putting the 5-volt power and then the ground, and we are using the analog input 0, 1, and 2 to get the input voltage of X, Y, Z direction. And we are grounding the each of the channel with the ground with the accelerometer ground. And after that, we need to set up. This will goes to the bottom of this plate, and this is the motor. So we'll take 2 burner cable. So the red one will connect with the red cable, and the black cable will connect with the black one. And black goes, and we'll use the 25-volt power supply. And here we can select the 25-volt here, and we can put the output on and off. So you can this is now off, so you can turn on output. So after that, you can, with this dial, you can set up the voltage to 2 volt. Okay. So after this, this is the lab setup. So after that, we need to set up the NI DAC on the lab view. So we'll go to the express input DAC assist, and we'll drag this one here. So we are acquiring the signal analog input voltage. So this is not turned on, so we need to turn on this one. Okay, so last time we just select the analog input 0, but this time we are using the 3 analog input. So we have to select with this controls key. So you select one of the analog input 0, and then control 1 and 2, and then finished. So now you can change the sample rate, like as you have like 5, you have to require the signal for 5 to 10 seconds. You can change it as you wish. And then that's the end sample. So we have 3 analog input 0, 1, 2. So that's okay. So after this, we need to require the signal splitter. So we go to express signal manipulation and split signals. So we'll put here, and we can just drag to make it bigger. So we need the 3 splitters, so you can adjust the size. So this goes, the data goes to the signal splitter. And then on the front panel, we'll need the 3 graph, waveform graph. 1, 2. So we need the 3 waveform graph here. So after that, we can just connect all these waveform graph. Okay, so this is a waveform graph. So now what we can do is we can just hit run, and we can get the output voltage, that's X, Y, and Z. So like last lab, we did the calibration of the accelerometer. So same way we have to do the calibration on this lab also for each axis. So for that one, what we need to do is, let me delete these 3 lines here. and we need to add the formula, and after calibration and calculating the formula, you need to insert that formula. So again, so express arithmetic and controls, so you go to the formula and drag 3 of these, and you can just, after you did the calibration, you can just insert the formulas here. Just connect all the wires. So the most important thing in this lab is you need to do the calibration how you did in the previous lab and insert the formula on each of these box. So after that, when you insert the formula, after that you need to do the each experiment measuring the XYZ direction of the voltage on this graph. So for that one, you need to change the voltage. So we start from 2 volt, and with the increment of 2 voltage, you can do for 4 volt and hit run and record the data. And you can do this like up to 12 volt. And once this experiment is done, so you need to turn off the power of the power supply, and you need to open this screw, and you need to set up this plate on with the vibrator isolator like this, so rotating it 90 degree. So after that, you can do the same method. You can supply the power using the 2 cable and use the accelerometer to measure the measuring the acceleration of XYZ direction. One you can do it for the base plate, and the other one you can do it for the motor plate also. So you have to collect all the data. That's all.